Hi, everybody. Thank you so much for attending our CU Data Week in 2025. We're so excited to have you be here. So we are going to be having sessions every single Monday through Thursday for the next 2 weeks. Every day at 12 p.m. MST. And then we are also offering office hours on Friday, this Friday the 7th, and next Friday the 14th. So if you have any questions from the seminar or any of them this week, and you maybe were playing around with working on code and doing following the code from any of the seminars and you are had issues or anything like that, you can come to office hours and we will help you through any questions that you have or anything like that. If you have yet to sign up for any other CU Data Week seminars or you haven't signed up for the Friday office hours, I'm putting a link into the chat. This gets you to the CU Data Week website, and you can go to the bottom where it says register now, so you can register for additional sessions this week. Tomorrow we have data management in SAS, and then we have introduction to REDCap, and then how to work with a statistician this week. And then next week we have more advanced seminars on R in SAS as well as REDCap. So we would love for you to attend. And then please stay till the end of this seminar. I will be posting in the chat a link to an attendance survey. This should take like less than 5 minutes for you to complete, but we really want to get your feedback on this seminar as well as what you would like to see from us in the future with CU Data Week or even the CETA short courses, which we have going on as well, that you can go to our website, go to see short courses. We have data visualization. We have fundamentals of electronic health record. So we'd love for you to sign up for one of our courses. You should have access to a Dropbox for CU Data Week that gives you access to all of the presentations, all the code, all the data sets that you need for all the seminars this week. And I will be posting everything for next week, this Friday. So like I said, please stay till the end to do the attendance survey. For every single survey that you complete, you get entered into a raffle to win one of 5 $75 Amazon gift cards, and these will be electronic. So you will get them within a week after all the sessions are done. And so today we're here for basic data management in R with Colin. And Colin, I will also, sorry, he's not really going to go over on how to download R or R Studio. We have the Intro to R folder as well. You received a YouTube link. It's about a 25-minute video on how to access R, how to download R and R Studio, and then kind of just a basic review of the interface of R, what a data table is, how to import some data. So if you have any questions about that, you can go back and watch that video. So now off to Colin.
All right. Well, thank you for that, Samantha. Fantastic intro. And thank you everybody for coming. So I guess my thought was just to go through this PowerPoint briefly and then do a walkthrough of the code of some of the important aspects we want to highlight today. So again, you guys should all have Dropbox access for that. But let me pull up our slideshow here. So again, this is basic data management in R. I'm glad you guys could all make it today. If this will let me click through, maybe not. Nope. And we click through everything at once. Okay. So again, I guess gonna go pretty quickly through installation of R and R Studio, kind of gloss over that, and then I'll talk a little bit about the types of objects and operations that we use most commonly in R, packages and how they're installed, and importing data, and then some brief data management, data summarization, um, creating transforming variables, and exporting data, all things that we do pretty commonly um, within R and within the statistics world in general, I suppose. Um, so again, we have, in case you haven't already watched the YouTube video, we also have some brief instructions on downloading R and R Studio here as well. Downloading R, technically you will be able to run these code strips just by downloading R, but I would highly recommend downloading R Studio as well, just to provide a more user-friendly, especially beginner-friendly interface for that, where you'll be able to, I guess, kind of separate your code and how you want to run it, be able to rerun specific chunks more easily, and you'll be able to easily, see your variables, data sets, et cetera, that you've created, as well as plots, and also some tutorials and code help documentation for some of the more common packages. So these are a lot of the objects and operations that we're going to be working with today. So in our vectors are probably the most common, where you can have vector, it's essentially just an object that contains one or more than one of any of these data types that we have down below here: numeric, logical, character, whatever you have it. And then as you build up to lists, which can contain multiple vectors, you can have lists within a list, etc. And we're sort of building up complexity here towards a data frame, which we'll work with very commonly, where you have, columns representing certain variables, and then rows representing individual like records, essentially. And then we have very common operations here as well, most of which are similar to math symbols. I'm sure you guys have already seen. The ones that I would more specifically like to highlight are really to this last one: assign value to an object. We have the caret and then the dash. So we want to use that to assign values to our variables, as opposed to doing that with the equal sign. The main reason for that being just to avoid confusion, because we can also have logical statements saying, is this thing equal to another? And when we do that, we use this double equal sign here. So you guys will get to see some examples of that once we get into the code. And then moving forward, just some general tips that tend to be helpful, especially as you start to develop longer code scripts, just to find a clear, consistent order and an effective layout for what you want the software to do. A very common way of organizing this is to load in the libraries, the packages that you will need in R before you load the data. Then load the data, load in everything that you might need, and then start your code for actual, data management, cleaning, followed by the analysis, and then saving any results that you need. And you can use as many line breaks, comments, etc. as you want. We'll talk about that. Just to break code into kind of distinct chunks that you can run one by one, so that if you do have errors pop up, they'll become easier to spot that way. And it is helpful to walk through things step by step, just to make sure your code is doing what you think it is. Comments, very important, where you can basically write whatever you want to help explain what your code is doing. That's very helpful for if you're picking up your code again after not looking at it for a long time, or if you're trying to read code that somebody else has written. Those comments can be very helpful. And then just trying to write variable names that are concise, that are unique, clearly differentiable if you have multiple variables that are similar, and then provide an accurate definition. And I will highlight R is case sensitive, upper and lowercase do matter. Um, so a lot of times we just use all lowercase for everything, and then we'll separate words with an underscore. That's kind of the most common way that I like to do it. Um, and then this is just a brief summary of the example data that we will be working with today, looking at relationships between variables of mothers and babies, um, such as weight, height, and basic demographic information. And so we'll kind of you guys will see once we go through the tutorial for that. And then helpful resources. The good news about R, besides the fact that it's free, is it's also open source. The documentation for all of the packages are all readily available online. And there are lots of resources, even just Google will, and that'll often send you to other websites like Stack Overflow. That can be very helpful. So if you're running into issues, there's no need to stress about it too much. It's going to most likely be an issue that somebody else has dealt with before, and the answer will probably be relatively easily available online. So, with all of that said, I think now we will go into the code. This. Okay. Is this a good size that everybody's able to read it? Okay. All right. Yeah. So this is our studio, and I guess before we really get into the code, I'll just do a quick rundown here. So I have it breaking up kind of into four sections. So here we have in the upper left we have our actual code script. This is what is saved to your computer as a file, and we will run through this. Down on the lower left is the console, and that's where, as we start to run through these lines, you'll be able to see in the console which lines have run, and you can type anything in there you want to run it outside of this code script, should you so desire. In the upper right, you have some a few other boxes. The most important one probably is this environment box. Right now it's empty because I just opened our studio. We haven't run anything yet, but as we start to import data sets and create variables and such, those will appear here. And it'll give you a good summary of what sort of data you all have loaded in and available to be working with. And then in the bottom right, we have a few boxes that'll be helpful. We have this help function where you can type things in right here. And right now it's the documentation for this package. I can type in the documentation for another package, and it'll show up. And then you can also look at packages that you have installed. And if you create any plots, they will also show up right here. So starting off now with our code script, I guess the first thing you guys can see is this header. And we use comments to make this. So again, a comment is basically anything that you add at all to help kind of clarify what is going on within your code script. And this can be anything at all that you want. So you start a comment with this one of these pound signs, and then after that, anything that you write after that on that same line will be part of the comment. It will not, trigger any functions in the code, but it will just show up. So I can type right here in this box at the bottom. I'll start the comment, and we can just, what is that? Why can't I see that? So I can just type, "Hi everyone," and that comment exists, but nothing runs. So as you can see, we still don't have anything in our environment. So now I think we'll look into variable creation to get things going on. And there are a few different types of variables that we're going to talk about, both creating and then converting back and forth between the types. So one of the more common ones is going to be a character variable. That is going to be basically anything you see these quotation marks on either end. Any variable that you create contained within those quotation marks is going to be a character variable. So here again is our assignment symbol. So what this line means is we're going to create a new variable named x, and we're going to assign to variable x the character value hello world. So I am just going to run this one line, which I do. You can run lines directly from this script by pressing Control Enter. So now we have this value x that shows up here in our environment. Now on the second line, we just have x. We're not assigning anything else to it. We just want to see what x is. So if I run that, then down in the console, we'll be able to see that x has this value, hello world. And then we can also use this class command on x or any other variable. And this will just output the data type of x. So x is a character. Going forward, creating a numeric variable, we can do the same assignment, really, to a new variable y, and we want to assign y a value of 2. So we'll use basically the same syntax. The difference in numeric is we're not going to put it within these quotation marks. We could, in theory, put quotation marks around the 2, and then it would create a character variable with a value of 2. But if we want to, do math operations and stuff on that, we need it to be numeric. So we need to omit those quotation marks and just have the 2. So we'll kind of see going forward. You can go back and forth between those if you need to. But running these same as before, we have it appear in our environment as a value. We have y set equal to 2 with the class being numeric. So now starting to look at changing some of these data types. I guess first let's look at just initializing a vector. So a vector can contain as many of these items as you want. But in order to initialize a vector, we need to have this C parentheses, and then you can list as many items as you want within these parentheses, but you need this C at the beginning to initialize a vector. This is definitely something that we do very commonly. So here we're going to initialize a vector. B is what we're going to call it. So we're assigning to B this vector with true and false within it. So another type of variable that we will be looking at is logical variables, for which there are only 2 potential values for this, true and false. So we're going to run this. We now have a vector here. We can print that and then look at the class. Oh, this is actually character class. And the reason for that is because, again, we put these quotation marks around the words true and false. And that's great if we want a character class, but we don't. We want logical. So what we can do is use the function as.logical, which will change any variable to a logical data type within reason, depending on what the input is. But we can actually call upon this itself. So we said set B as the logical transform of itself. So it's okay. It's okay to do that. You can directly overwrite a variable in this way in R. You have to, I guess, generally use some judgment as to whether that's the appropriate thing to do if you want to overwrite a variable or if you want to make a new variable in the different format. But in this case, since it's just true and false, we're going to overwrite and then print B again. And now you notice that the quotation marks are no longer there when we're looking at the output. And that means that it has been successfully transformed to a logical, and we can confirm that by rerunning this class function. So for numeric variables, we can do something similar. So we're going to initialize a vector A with values of 1 and 2. And unsurprisingly, this is currently as class numeric. And we can run a very similar function to change this to a factor instead of a numeric. So now when we output A after running that, it shows you the new levels of the variable. So we have a 1 and we have a 2. Those are the two options that variable can be as of right now. And of course, we could create additional levels if we so desired. And we can run the class statement to confirm that that is a factor. And I'd say on the whole, dealing with vectors like this, you generally don't end up transforming many of those two factors, but those do become very important when you're dealing with more complicated analyses. You start getting into, regression modeling and stuff like that. You need to be very cognizant of whether your variables are being handled as continuous numeric predictors or categorical factor predictors, as that can have a major effect on the model. And then we can do sort of the same thing with, remember this y that we have that's set equal to 2. We can change that to a character with as.character, all very similar statements to change the class. And if we print this here, oh, now this too has the quotation marks around it again, because it is a character variable. And then we can transform it back to numeric with this statement. And at least in terms of character numeric with, numbers, that's a transform that can be made very easily. And it's an important thing to consider when you're reading in data. Sometimes it will automatically be read in as a numeric or as a character. And if you're trying to use that data to do more complex analyses, you will have to be cognizant of what type it is being read in as. But assuming your data is all, in this nice, clean numeric format, you'll have no problem changing it back and forth if necessary. So these functions, the vector initialization, the as.numeric, as.character, and the class function, these are all within what we call base R. These are functions that are already loaded into the R system as soon as you open it. But there are a lot of additional functions that people have written that are very, very helpful that are not automatically loaded in that way. And so for that, we use packages. So we have a couple different packages that we're going to load in today just for kind of basic data management. So in order to use these, you have to effectively run two different lines of code. So for the package tidyverse, first you would want to go and run install.packages tidyverse within quotation marks. I'm not going to run this because I already have this installed. This is something that you only need to run once for each package, unless you like update your version of R or something like that. Then some of that might be cleaned, but and then I suppose you can also rerun this if the package has been updated. If you'd like to get a more current version of the package, some of the packages are maintained and regularly updated. But for most purposes, this is something that you'll only have to use once. The command that you will have to run every time that you open and close R is this library command. Basically, just to go back, find all of the functions and such from this package tidyverse and load them in so that they are actively ready for use. So I will run this, and it'll maybe take a while to run, but ultimately this will just show there are dependency packages here. So this tidyverse package actually relies on all of these other packages that get loaded in. Bottom line is you don't really have to be too concerned with what's happening in the console when you're loading in these packages. And so I'll do that for these other two as well. Tidyverse is a very common package just for data cleaning and management and such like that. There are a lot of very helpful functions in there. Table 1 is used to produce a table 1 effectively, or any other sort of summary table. That can be very helpful to sort of put your summary output in a manner that is much more digestible. And then lubridate is just a package that's helpful in handling dates. And if you want to get help or information about any of these packages or the functions within them, you can always run this question mark and then the name of the package. So here, tidyverse. And then this should, in the bottom right here, will open up the page dedicated to that package within this help window. And we can scroll through this. This is just a very brief summary of what some of the package is for. There's links to the documentation for the package online. A lot of this is going to be very, very hefty. It may not be all that helpful to read through it, but you can also go into this box here and search for specific functions within that package. And if there's a specific command that you're trying to use, I would recommend searching for that command, and the information you'll get there will likely be a lot more helpful. So importing data. So we just have the one birth weight data set that we're going to load in today. So this is the line of code that I'm going to use to do that. We're going to assign it the value df data frame is what we're going to call this today. And then we're assigning to that the output of this function. So this function is read.csv, which will read in the data for any data file that you want to read in, provided it is in a CSV comma separated variable format. So you just put in here, this is the name of the file and then the file pathway to do this. The other option for this, if you don't know the file pathway or don't want to hard code something like this, is you can do read.csv, and then within this function, we're going to call another function file.choose. And then this will actually open up a whole, I guess, I don't know if you guys can see it. This will open up a whole new window. And you can actually go through the files on your computer and select the specific file that you want to open. And then if you want to open a file that is in an Excel format, it's a very similar structure. You need to call this function read Excel. And in order to do that, you do need to download this package and read in this library. But overall, very similar syntax for Excel files as what you would get for a CSV file. And those are the two most common file types that I find myself importing into R. So let me run this CSV. And you now see here, we have a data frame loaded in called df with 50,000 observations of 12 different variables. And so I can click on this and it'll start pulling up the data frame, and I can browse through this however I feel. We have our records in the rows, and then the columns, we have each of the variables that we're looking at. We have an ID number, weight, race, etc. So if we want a quick summary of the numeric values of the entire data set, we can just run this summary function and call df into it. And that'll give us in the console a lot of information about each of the variables that we have in here. And this is helpful, certainly, but this is also a lot to digest. Especially, you can imagine if you load in something with 100 variables, you're not going to want to look through this like that. You are going to want to, choose your specific variables that are of most interest and kind of go through it that way. So you can actually use this command to look at a specific variable within the data frame. So in this case, we want to do this with weight. The way to basically call a specific variable within a data frame is name of the data frame, $, and then the name of the variable that you're looking at. So if we look at that, it gives the same output for just the variable weight. And now I'm looking at this, and I have to consider a little bit, okay, do these values make sense for the variable weight? Well, I have a median of 3,402, mean of 3,371. And I can say, well, that clearly doesn't make sense if the weight is in pounds. But we have, a few different variables. We have actually multiple variables for weight in this data set. And so I can say, okay, if this were to be the baby's weight at birth in grams, 3,371 grams is a mean. That's around 7 pounds. That makes a lot more sense. So, you look at a summary, you do have to kind of have some context for the variable in order to kind of confirm that. Because even then I can say, okay, I think that makes sense for the median or interquartile range. All of that looks good. Minimum of 240 maybe is questionable. Maybe that specific value was entered incorrectly or something. But other than that, it looks good. But anyway, considering context when you're looking at these is definitely important. It's very, very helpful to have a general background knowledge of what sort of data you're looking at. If we want to just look at specific, a few examples of this variable. We can use the head function, and that will load the first 6 values just from the first 6 rows. You see these are the values from here. If you want to call more than 6, you can alter this function, add another argument here with the number that you want to call. And so now we get the first 10 of them. You can see the first 6 are the same, and then we have 4 additional values. And then we'll run the class statement for that as well. And we see that this is an integer. So now let's run this summary statement again for the race variable. And this is ultimately not helpful. But it does tell us that it is a class character variable, which makes sense because, R is not going to be able to calculate a mean or an interquartile range or anything like that for a character variable, which is fine. Because if we look at race within our data frame, we say our values are Asian, white, native, etc. So we're more interested in the frequencies by which each of these values populate. So we can actually do this by transforming to a factor and then running the summary command, and that will give us the tables with how commonly each of these values show up. And actually, you can also do this just by running table and then calling the same variable, and that will give you the same output. We run this for the mom weight, however, then we do get min, max, mean, all of that stuff, because this is a numeric variable. So if you noticed, for each of these variables, we do have a few values that are missing. We have 127 subjects that don't have a race listed here. And then for mom weight, we have 81 NAs, which is the most common way that missing is coded within a CSV file that you would load in. So we can use this file to see basically how many missing values are in each of these variables. So if you take a variable, the is.na, what this basically does is converts everything that is NA gets converted to true, and everything that is not NA, anything that has an actual value in it, whatever it is, gets converted to false. And then this sum function will just add up all the trues. So that'll tell you how many NA or missing values you have in yours. So we run that for mom weight, and it says 81. We run that for race, and it says 0. But we know that we have these 127 that don't have anything applied to it. And the reason for that is that there are actually multiple ways of coding missingness. NA is going to be the most common, but it is actually possible to code something as this empty string here. It's a character variable, but with kind of nothing in it, basically. And so we can do something similar where we'll say sum the race variable is equal to, with the double equals, the empty string. Oops. And so that happens 127 times, and that's where our other number comes from. So let's call that table1 function that we mentioned earlier. and kind of get a basic look at what our data looks like. So we'll call data equals our data frame. And then these are each of the variables that we want to look at, with some of them being converted to factor. So this will give you something in the window at the bottom right. And we can see we have 50,000 overall subjects. On the left, we have each of the variables that we're interested in. And on the right, we have the frequencies. And then for numeric variables, it'll populate mean and median, and then the number that are missing. So this is probably the most helpful type of general format to give a brief, high level summary of everything you have in the data. But this is also something that we can clean up a little bit. We're creating tables for presentation. We'll want to rename this so it doesn't say factor parentheses. We can clean some of these levels up. We may want this to say married and unmarried instead of 0 and 1, stuff like that. So the rest of this code is going to briefly go over how we can make some changes to do that. So first, we are actually going to create a new variable within our data frame. It's going to be called low birth weight here. And so we are going to assign to this low birth weight variable this if-else statement. So what this says is take a look and evaluate this, this statement right here. For each row, is the weight of the baby less than 2,500? If that is true, then we assign low birth weight a value of 1. If that is false, then we assign low birth weight a value of 0. So we're going to run this. And now you'll see we still have 50,000 observations, but instead of 12 variables, we now have 13. So we can do similar things here. We're going to create another new variable for BMI. This is just a formula for BMI, but you can, instead of the if-else statement, we're just going to take some of the other variables that already exist and do some math. And we can do that and run the summary. And we can say, okay, we have some more missing values, but for the most part, these numbers make sense. But what we have here is just all numerical values of BMI, and it might be more helpful for us to create categories. So there's a few different ways to do that. But we're going to create another new variable for the category. And we're going to use this case when statement. So this will basically allow us to define as many different cases within the previous variable as we want, and set the new output of BMI category based on that. So if the BMI is less than 18.5, we assign the new variable 1. If it is greater than 18.5 but less than 25, we assign the new variable a value of 2, and going on and on. This also, a statement like this, by the way, is where it's very helpful to kind of break up after each of these commas, use a line break just to make it much easier to read. So we'll run that and then look at a summary of BMI category as a factor. And so we have our 1s, our 2s, our 3s, and so on. And so now here we're actually creating a new data frame with these two specific variables, BMI and BMI category, that we can use to make sure everything is correct. So we look at here, we have a bunch of NAs that are assigned to 5. If I scroll down, we have, 43, 41 are assigned to 4, 24 is assigned to 2, etc. And so we can say, okay, these all make sense. And then going back to the missingness in that race variable, we're going to use this if-else statement again to define a new categorical race variable, which we're calling race underscore cat. So now we're actually calling the old variable twice. So what this will do is if race is equal to this empty string as we identified before, it will convert that to NA. And if it's not, if we already have a value, well, then we're just going to keep that same value and assign it to the new one. So both the new and the old variables will have the same value, except in the case where we have this empty string, the missingness. So we're going to run these. We can run the summary code again. And this time we have 127 NAs instead of 127 with that blank, effectively. We can also use if-else to create these dummy variables where we can identify specific levels of this race cat variable. So we'll say, black, white, etc., where these variables now, instead of having the levels black, white, etc., we'll just define them as basically as logical value. I think the way they're coded up here, it's technically a numeric, but they're effectively logical values where every value will be either 1 or 0. Where this one says, for our new variable black, if race is equal to black, set equal to 1, otherwise it's 0. For our new variable white, if race is equal to white, set equal to 1, otherwise it's 0. And etc. for each of these levels. Then we're going to look back at that low birth weight category again. See our class is numeric. Reminder, these are the values that currently has. For BMI, these are the values that occur. Right now it's a 0-1 variable. So we want to kind of keep it that way, but we want to include it in the table going forward. And when we output this variable into the table, we don't want the labels to say 0-1. So we can use this function. We'll take the 0-1 numeric variable. We're going to convert it into a factor. And then we'll say these levels, which is what we have right now, are going to correspond to these labels. So a level of 0 corresponds to normal weight, and a level of 1 corresponds to low birth weight. So after we run this command, once we rerun our table 1, then you can see in a similar spot to where these factor married these labels will no longer say 0 and 1. They will say normal weight and low birth weight. And there's no limit to the number of levels and labels that you can code in this manner. They do have to match. But we can do the same thing with this BMI category that has 5 levels instead of 2. So instead of reporting as, we don't want the table to report as a continuous measure where it'll give us a mean. We want it to report as the frequency of 1, 2, 3, 4, 5, but we want the labels for 1, 2, 3, 4, 5 to be underweight, normal weight, etc. So we can run the same command with with BMI category. We'll run it again here for smoking status of the mother. And then for our race category, that we don't have to rewrite the labels because it's already labeled in the manner we want. But it is currently a character variable and we want to transform it into a factor variable. So we're going to do that. We look at the summary, it looks the same. And then those dummy variables that we're talking about, those are currently 0, 1 numeric. We're going to transform all of those to factors as well. And then just looking at labeling our variable names as they are in here. So right now they'll say, factor race or mom WT or something like that. We can spell this out so it actually says weight, where it doesn't have to be the way that we've named our variable here. And it's a very easy command to do that. Just label parentheses your variable of interest, and then you set that equal to a character value of whatever you want, really. So we're going to run that for all of these, which currently have kind of messy labels, but running those new labels. And then we will rerun our table 1 command, and that'll update what we have going here in the bottom right. So if we look at this now it's a nice name of race, and we have all of these categories as we want. For some of our dummy variables, we still have it as 0 and 1 because we didn't change the levels there, but it does now report as a factor variable and not as a numeric variable, which is important. And then we have these other ones. So this is low birth weight before we transformed it to a factor, and this is after we transformed it to a factor. So this second one is really what we want, but you see we've updated the label, and then we've also updated the levels of the variable that we're interested in. So it just says normal birth weight and low birth weight instead of 0 and 1 or something like that. Here for BMI, we can still look at the continuous measures of BMI. It is a number. It can still have a minimum, maximum, and stuff like that. But then we also have the 5 categories that we assign to it based on what that numeric value is. And then mother smoking status is now split up into yes and no as a factor rather than a numeric. And so when you call this table 1 function, we still have other variables that we're not including in this table 1 right now. You can add as many variables into table 1 as you so desire. There are also ways to stratify table 1, where if I say I want a table 1 stratified maybe by mother smoking status, we can look at the demographic information for all of the mothers who do smoke and all of them who don't separately, and then have an overall column on the right. That's also something that you can do. And then finally, exporting data. So after we've made all of these changes to our DF, we are going to create a new data set called df_clean, where basically we are just taking the old data frame and we're using the select function and this -c. Basically, all of this does is it's just going to copy the exact same data set, but it's going to remove these 2 variables that we're no longer interested in. So if we run this, we see the df now has 23 variables, df clean has 21. And then the command to export is write.csv, which is run very, very, very similar to reading in with read.csv, um, where you, but now there's two arguments. First, you pick the data set that you want to write out, um, and then select the file path and file name. And the only thing I would highlight here is especially um, you probably will want to save it to the same location as the old data set, but you're definitely going to want to choose a new name for the updated data set here. I'm choosing birthweight underscore clean to highlight that this is the cleaned data, not the raw data. You want to be very careful not to overwrite the raw data as you're writing out your data that has been cleaned. And then I think that's it. I have a couple extra functions for this that we can go over if we have time. It looks like we're almost at time. Otherwise, I don't know what if there are questions, we can take questions. Samantha, I don't know what else you had in mind.
No, just if anybody has any questions, and also the survey link is in the chat, but it looks like Gabriella has a question.
Thank you so
Sure.
much, Colin. That was really great and so helpful. I know that someone put this in the chat, but that table one, you have to download the package first. Is that right?
Yes.
Okay, and then my other question is table one with a numeric one is different than table one spelled out because I think there's another package.
That is correct.
And then lastly, can you export table one specifically, or do you just copy and paste out of your visual of where it shows up?
So here, I think you can go export and save as image. Like I think that's a way to do it from here. If you have something that you are going to be running multiple times, my recommendation would be to run all of this code in either an R Markdown or Quarto document, both of which can run in RStudio. And that will allow you to, as it basically as it runs through the code, it will print all of the output that is generated from that.
Yeah.
And then you will be able to knit that to an HTML file or a PDF or something along those lines, which will contain the tables that you output if there are any.
And we have next week, we have advanced reporting in R, which goes over all of this stuff. So that might be a really good seminar to take.
I'll be there. And then last really quick.
That's a great question.
I know we're running out of time, so I'll just wait for next week. Thank you so much.
Oh, no, you can ask your question if you have time to stay.
You mentioned that you could stratify by, say, maternal smoking status. How would you write that code for that table one? How do you put that categorical by this?
So I'm just going to copy this and kind of edit it down. Actually, let's just do it here. So table one, let's just take these first three, maybe. Oops. And then I think in table one function, the way you could do it is with this vertical bar on the shift right above the enter key. Mm-hmm. Do that after the variables that are all that you want in your columns here, and then you can put one variable here after that line that you want to stratify on. See, did that work? Yeah.
Oh, yeah. Awesome. Thank you so much.
Yeah. So this will give you no, yes, smoking status. And then overall, I think you can do something within this command. I believe you can also do like overall equals false or something if you want to hide that last column.
Okay.
And then there are also, I actually haven't used this command in a while. There's also ways to add like headers and stuff. So you can clarify exactly what this no and yes means.
Right. No, that's great. That's so helpful. Thank you so much.
That's one of the cool things about R is that there are so many different packages that they do similar things. And there's a lot of documentation online. So like if you want to learn more how to use Table One, you can go to that documentation and there's so much code and examples and it's really great. Are there any other questions? Awesome. Thank you, everybody, so much for being here. Remember, take the survey. The link is in. I had added it to the chat. So make sure it does enter you into a raffle to win a $75 gift card. So thank you so much. And we hope to see you tomorrow. Bye.
Thank you, everyone.